Okay, so welcome back to example 3 in our notes for domain and range of functions in interval notation. And in example 3, we're going to have our first experience encountering discontinuous relations and functions. And so you can see here 1 over the quantity x plus 3 plus 1, that's a rational function. And any value that would make a 0 in the denominator of a fraction causes a break in the graph because there's something undefined at that value of x. So for example, if x in this example was -3, we'd have 1 over -3 plus 3, which is 0, and you can't divide by 0. So that's at -3 why there's this break in the graph here. And that creates something called a vertical asymptote. So if you recall from Algebra 2, we would draw those in as dashed lines, but they didn't exactly, or didn't really exist on the graph. We just showed that break in the graph with a dashed line. The range also, because we can't put in a -3 for x, it produces a break in the range as well, and that's represented by this horizontal asymptote here at 1. Oops, it got a little wiggly. So here at 1 on the y-axis, we have another asymptote that is causing a break in the graph, because since x can never be -3, we're never going to have an output where y equals +1. So when we look at this graph, it's divided into two sections. This rational function makes a shape called a hyperbola, and the domain, because there's two sections, is going to be requiring two intervals joined by this union symbol. So if we look from least to greatest, right, we start at the left side of the graph. This is where our function is picking up here at -infinity in the x direction, and it keeps going, and approaches but never actually equals -3, because it's going to head down forever, getting closer and closer to this asymptote but not ever touching it. So our domain is the interval -infinity to -3, and it can't touch -3, so we have an open interval. Okay, then we pick back up again though on the other side of this asymptote where the graph is approaching this -3, right, getting closer as it goes up, but never actually equaling -3, and then it comes down and goes on toward +infinity in the x direction. And so the domain is going to need a union, and then we reopen this interval at -3, right? It's open because we can't have it equal -3, and then off to +infinity. Okay, and that would be the domain. Okay, the range is from the bottom to top, so starting with our lowest y value down at -infinity, we are going up until we see here the break in the graph at +1, and it's non-inclusive, so it's an open interval. Then union, because we're going to pick back up again on the top side of that horizontal asymptote, and then that goes up to +infinity. So all real numbers except +1. Okay, and is this a function? Yes, it passes the vertical line test. So we put yes, that is a function. Okay, so go ahead and pause the video, give example 2 a try, and then restart when you're ready to resume. So welcome back. Hopefully you got a chance to try number 2. This is x over the quantity x² minus 4. It's a rational function. That denominator x² minus 4 would cause a 0 in the denominator if x was either -2 or +2. Both of those x values would cause this function to be undefined. And so we have a vertical asymptote here at -2 and at +2. And so the domain, as I read from left to right, least to greatest, my domain is starting starting at negative infinity. So we'll go ahead and open this interval at negative infinity. Then we head from left to right, approaching negative 2, but never actually touching it. So negative 2 is open. Then we'll have a union to join that with the next interval, which picks up again on the other side of negative 2 and keeps going continuously through here until positive 2, right? We're approaching but not touching positive 2. So negative 2, comma, positive 2, and that's an open interval. Then union, because we have a third piece now that we need to represent in the domain. Excuse me. So we pick up on the other side of positive 2, and then this graph is extending on toward positive infinity. So open at 2, and then positive infinity. And that's our domain. 3 intervals joined by a union. Okay, now the range, when we look at this graph, we have a horizontal asymptote shaping the edges here. So we can see that all the way to the left, this end is approaching 0, right? Getting closer, 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 but never going to cross it. Here on the right side, the end is approaching 0 again, closer, closer, but never going to cross it. However, horizontal asymptotes, even though they can not be crossed on the far ends, the left end and the right end, they can be crossed through the center. And we see here this point at 0, 0, that's where this center section is crossing that horizontal asymptote. And so even though it's shaping the ends, it doesn't actually cause an interruption to the range, because the center section is continuous all the way from negative infinity to positive infinity. And so the range here is all real numbers. Okay, and is this a function? Yes, it is. It passes the vertical line test. It's a rational function. Okay, so pause the video, give number 3 a try, and then come back when you're ready to resume. Okay, so welcome back. We're ready to go over number 3 together here. And this is called a piecewise function because it's made up of pieces of multiple functions. So that's different from the first and second problems that we did here, where this hyperbola with 2 pieces, 2 sections, is made from one function, right? That is the graph of this one function. If you typed it in the calculator, you would get that picture, right? Same for 2, it's a rational function. It has 3 distinct separate pieces to its graph because of these asymptotes breaking it up, but it's one function. 3 is called a piecewise function because it has 2 distinct pieces. There's a line segment here that's a piece of a linear function, and then this is a piece of a parabola or a quadratic function. So as we go to write its domain, we're starting least to greatest. So over here, our lower bound for x is a closed circle at negative 2. So we're going to have a bracket at negative 2 to show that that's inclusive. And then as we go across, we want to record all of the x's that are possible. So the first place that we see an open circle that we want to consider is here at positive 1, negative 2. However, even though it's open here where x is 1, if I look up, I see that x is 1 at 1, 3 is closed. So 1 is okay for x. And then I go on, and this touches the edge of the graph, so I know that that's continuing on forever up and to the right. And so that means that my domain starts with a lower bound at negative 2 and then heads to positive infinity. Okay. Now the range is bottom to top, so I look for my lower bound for the y values, and that's down here at negative 2. So since it's an open circle, I'm going to start with a parentheses at negative 2 for the y, comma, then we look where the endpoint is, so we're going up, 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 up. Here at y equals 1 is a closed circle, and I notice that before I can continue on, right, I look across, there's nowhere to join up. There's a big gap here between 1 and 2 on the y-axis, right? This is going to be the next y value that I can refer to when I'm writing the range. So I'm going to need two intervals, -2 to +1, and the 1 is closed. And then I pick back up again with a closed circle here at y equals 2, so I have a bracket, and then I head over this direction, and here's an endpoint at y equals 3, but that's not the highest bound for the range. I can see that on the other side it goes up to the 3 and keeps going on up to infinity. So I have infinity as my upper bound for the range. So my range is -2 open to 1 closed, union closed at 2, and then on to positive infinity. Okay, when I go to see if this is a function, I want to see if it passes the vertical line test, and the only place that would be any concern for the vertical line test is here at the x equals 1, but because the only point that's included is 1, 3. It's open at 1, -2. This does pass the vertical line test, and so yes, this is a function. Okay. So go ahead and pause the video and try these two problems, and then resume when you're ready to go over the answers. Welcome back, and hopefully you had a chance to try A and B here. A is a rational function. We can see that there is a vertical asymptote here at +3, causing a break in the graph. That vertical asymptote is going to affect the domain. Okay, then there's a horizontal asymptote here at +2 on the y-axis, and that horizontal asymptote will affect the range. So the domain is the interval from -infinity to 3, union 3 to infinity, and it's open. Then the range is going from -infinity to 2, right, union 2 to infinity. So all real numbers except 3 are the domain, all real numbers except 2 are the range, and yes, this is a function. It passes the vertical line test. Okay, then in example B, we have a piecewise function with a linear segment followed by a square root, right? We can see that arc shape with an endpoint here. We have an open circle. So the domain starts at -4 and is closed. It goes on to -1, which is also closed. Okay, so that's going to be a fully bounded interval, closed on both ends. Then a union, it picks back up again with a parentheses because it's open here at 0, and then we go on to positive infinity. Okay. The range, bottom to top, so our lower bound for y is -infinity up to, but not including -1, and then we go pick back up again with another interval at +1, and then our upper bound is at 4, and that's inclusive. Okay, and then is this a function? Yes, it passes the vertical line test. And okay, so this brings us to the secret question for lesson 2, and that's asking us to use a graphing utility such as the TI-83 emulator, like what you see on the screen here, or you could use Desmos or GeoGebra. Whatever graphing utility you're comfortable with, you're going to graph these two functions and then refer to those graphs to answer these 4 questions for your secret question. Since this is the first time I've asked you to graph in this year in pre-calc, I'm going to go ahead and walk you through how to do that in the TI-83 calculator. If you're already comfortable with graphing, you can go ahead and just pause the video and get started. So for those of you who would like a little bit more help, you can bring up your TI-83 emulator or whatever graphing utility you're going to use. In the TI-83, press the y equals button, and this brings up where we can type a function. And we'll just start with this first function given by the equation y equals the square root of the quantity 4 minus x squared. So we'll press second, and then the square root is located up here above the x squared button. And the argument of that square root function is 4 minus x, and there's the square. I'm going to close the parentheses on the argument of that square root function and press enter. Okay, then I'm going to go to the graph here by pressing graph, and it looks like just a little semicircle. And I think I'm going to zoom in a little bit on that semicircle by adjusting the window here. So since the entire thing was above the x-axis, I'm going to set the dimensions to go from, let's do -6 to +6 along the x-axis, and then let's try -2 to 6 on the y-axis. Because it was above the x-axis, I'm going to just go -2 as my y-min, and then we'll try that and see how it looks. So yeah, that's a little better. It looks like it's zoomed in on that semicircle. Okay, now if you look closely, it looks like it's not quite connected here, and that is an issue with the pixels. So to double check where those endpoints are located, I can press trace and then type in any x I want and see if a y that goes with it appears. So if I put in, for example, -2 for my x, right, I get y equals 0. So that point -2, 0 is on this graph. If I were to type in -3, though, notice I get nothing back for the y, and that's because it's undefined at -3, because that semicircle intersects at the x-axis here at 0, -2, right? -2, enter, and I get 0. So I can now see that that is my endpoint. If I put in 2, just make sure, yep, 0 on the other side. So 2, 0 is my endpoint on that side. So I can use that information then to explain what is the domain and range, right, of that function in interval notation. Okay, the second one is easier because I'm going to need both of them on the same coordinate plane here in a second. So instead of deleting this first equation, I'm just going to arrow over to the equal sign, press enter. That turns off the graphing for that first equation. And now in my y2, I'm going to turn that on. I'm going to graph the square root of the quantity x squared minus 4, right? And graph that, and there's my second equation. And again, if I'm not sure whether this is touching here or if it's open at that endpoint, I can just hit trace and type in the value that I'm thinking about. So -2, enter, right? And so I can see I got a y value, -2, 0 is on that graph. If I'm not sure whether maybe it comes down, touches, and slides along the x-axis there, I can put in -1 or 0 and see if there's a point there. So if I type in -1, let's see, -1, enter, it's undefined at -1, right? So I can see it's coming down here, getting close, touching there at the x-intercept at -2, but then it stops, and there's this big gap in the middle, and then it picks back up again on the other side. I can test that by putting in 2 for my x, press enter, and sure enough, there's my endpoint at 2, 0. Okay, so that should help you to answer questions number 1, number 2, and number 3. And then question number 4 asks us to graph both functions on the same coordinate plane and then consider the domain and range of that combined graph. And so as I go back up here to my y equals, in order to graph them on the same coordinate plane, I would just highlight that equals that I had turned off, press enter, and now both of them are turned on. So when I press the graph button again, that would show me both graphs at the same time. Okay, and then you can go ahead and answer your 4 questions for the secret question for the lesson, and don't forget to upload those as the last page in your notes to Schoology when you're all finished. Thanks. And so that's a yes.